and welcome back to Code It with AI. I'm Carl Franklin from AvnDataGenie, and that is Jeff. Did I say Franklin? I think I did, Carl Franklin. I'm Carl Franklin from AvnDataGenie. That's Jeff Fritz from Microsoft. What's up?
Hey, how you doing, my friend? Happy 2026.
Yes, to you too.
Oh man, I feel like it's a year for new things, to experiment and try things out.
That's exactly what we've been doing, Jeff.
I know.
And we want to show people what we've been working on over the holidays. Let's go to the screenshot here. This is a new tool that we're writing. It's not written yet. It's called AvnDataGenie, AVN for AvnDataGenie. And yeah, we were struggling over a word, Genie, wizard, all this stuff. We wanted something to show you that it isn't going to be like an ORM or anything like that. And it's not really a wizard. It's just something that helps. Okay?
Yeah.
So it's an open source system to allow users to query a database using natural language. So let's just talk about our goals here. If you look back at the episode where we started this whole text to SQL thing, we were going to find an MCP for SQL Server, thinking that, oh, well, this is obviously the way that you do it. And it was just very difficult to get something working. And it turned out it wasn't very helpful anyway.
No.
And if you go out and look for, there's a bunch of SQL MCPs out there, and they all complain that everything stinks.
Yeah, they do.
I'll say that.
Yeah.
So what we ended up doing for that demo was bringing the context of the data schema and rules into an application where we can hit an LLM and we could construct this ginormous system prompt that had all the stuff in it, right?
Yeah.
And that it worked, but then we started thinking, there's got to be a more flexible way to do this.
And we decided to go in a slightly different direction.
Right. And so if you remember the one where we were querying with Copilot CLI, GitHub Copilot CLI, we were just doing some data analysis on a database. Well, we really wouldn't want to hand that over to a user, and allow them to just ask questions about data because there's no guardrails.
So we also know that our projects have a shared nomenclature. They have a glossary around the way that we refer to our objects, right? So we want to make that accessible so that you can use those terms and phrases that your customers, your users are familiar with to interact with the database.
So there's basically three parts to this. The first thing we need is a schema generator. So you use a connection string. And by the way, in the future, we envision this not just being for SQL Server, but anything, right?
Any data store.
Any data store. So the first thing is to generate that schema, and it's going to get the primary keys, the tables and columns, the foreign key relationships and indexes and column constraints, and export that all to a JSON file. So that's easy to do, right? We've done that part. The next part is to take that JSON and then configure with an administrator program how the LLM interacts with your database. And basically, we want to provide friendly names or aliases for tables and columns, right? As it says here, customers instead of table cust. These are natural language things, aliases, right?
Yeah.
Some descriptions, some PII or restricted fields marking, and some other things. So join hints, right? We automatically generate join hints from foreign key relationships and allow you to add, edit, and remove those, and then descriptions for those joins. Some required filters, some business terms. And then that is going to produce yet another JSON file. And then these two JSON files create the context for an LLM to go in and process the natural language.
Yep. Generate the appropriate select statement or whatever read statement we need for your data store model to be able to deliver and return a cool report for you.
Right. So this is what we have so far. And again, this is still a private repo. We're working on this. This is just a local DB Chinook database. It could be anything, but we have a schema generator. So generate the schema, mouse wheels are turning, and there it is. So this is all in JSON, and it has all the information about all the tables and columns and relationships that an LLM would need to understand your database, right? We don't want to have to copy things around. We just want a quick way to generate this. And then we have another page here. This is where you create the rules that you make it more friendly, right?
Yeah.
So let's look at an album, the album table right here. We have a friendly name if you want to call it albums, for example, or aliases, record, recording, the description. Then we have the same thing here, aliases for columns like title, right? Could be name.
Carl, there's things in here that we know we have to evolve into, right? Looking at this, we know we're going to have to do things with security. Are folks allowed to read these tables? Are folks allowed to see these fields? And that's a little bit of what the restricted column is allowing us to do, is say folks aren't allowed to read these columns.
Right, but we obviously need more information about that. We might need roles or something like that.
Yep.
Yeah. All right, so then we have join hints. And right off the bat, if there are no join hints, you get a list of all of the foreign key relationships. And you could put a description in here, which might optionally say, in this case, are albums by artist or all artist albums or both, right?
The employee reports to, you could say, is the manager of type of thing.
Yep, that's right. Okay, so then we also have required filters. So you can select a table. And right now we don't have a column select, but you could put the column name in there. We probably should have a column select because we like drop downs. Mm-hmm. The filter type, tenant. Okay. Is this a filter by tenant? Only these tenants can access this particular table. A soft delete, is if this employee is not deleted, but has a is deleted key or something like that, right?
Yep.
And then a custom filter. And then we have some business terms, right? So you can see it's suggesting here like submitted grants, a description of what that means, and an example. So these are all things that the LLM can use to figure out how to generate that magic select statement, which is ultimately what we want.
Yeah. We could define things like a gold record, right? Is X number of units that are sold.
Right. And so the idea here is then to take these JSON files, both of them, and I've got them listed right here. Here's the database schema JSON, which we already took a look at. And here's LLM config JSON, for lack of a better word. We might come up with a different name for that, but basically this is the, the metadata that goes around the schema to define, what the parameters are and what the friendly names are and all that stuff. So the idea then is we're going to take both of these and load them into a runtime tool that you can then use to query an LLM and, point the LLM to these files to say, we want to use this metadata and this schema of the table. And in your system prompt, you want to put stuff like, we're only going to produce select statements. There will never be any insert, delete, or update statements. And follow the rules and return a select statement. And that's really what we want. We want a form in our application that our users can use to type in a natural language query. We pass it through our tool, and it comes up with a select statement. From there, it's all yours.
Yeah. So, right, being able to do things with our artist and music album database, to be able to say, hey, give me a list of the artists who over the last 50 years have sold gold records.
Exactly.
That's easy thing for us as humans to understand, but then to turn it into that join and that where clause and bring that all together, something that'll be a lot easier to do with the tools that we're seeing here.
And realistically, this is what we were doing in that last episode that we did where we used the GitHub CLI, Copilot CLI, to examine a database and mine it for sales information, right? For gems, for insights. This is exactly what we're talking about, except we don't want to have to expose the entire database and, all the system tables and all that stuff. I mean, you don't want the user to type in, show me all the, system table names and all the accounts associated with this database, which you could probably do in the GitHub CLI because it's using the whole admin context.
And setting up an MCP so that it can connect in and use your existing database and leave it open for different things to be integrated and allow for kind of pseudo-random SQL statements to be executed against it. That's not something that we want. We want more production-grade, enterprise-quality interactions with our database that we know are tuned and secure so that, importantly, our database administrator friends don't get mad at us.
And since Jeff and I both think in the future there's going to be more people using local Ollama-style LLMs on their
Azure
own hardware.
Foundry, Ollama, Hugging Face, all those.
That this is going to be kind of the future, especially as, well, I don't know about you, but I think there's an AI bubble happening here, and prices may come down dramatically for these things, which might make it more affordable to do them locally. But also, you have, as we mentioned in the Ollama show, you have businesses that don't want to share their schemas and secrets and databases with the big internet LLMs. So we're setting ourselves up here. It's not done, and it's still a private repo, but we want your feedback. So of course, if you have any suggestions, send them to Jeff and myself at codeitwithai@apvnext.com. And at some point we'll open up this repo when we think it's good enough, and we'll talk about it again at that point.
Yep. Look for the update.
Yep. So we'll see you next week. Thanks.
All righty. Take care, friends.
Thanks for watching. Make sure to check out blazertrain.com and blazerpuzzle.com for more great content.